Cnc Automation Introduction. Cnc Computer Numerical Control. Automation is a technology that enables machines to operate with minimal human intervention by following pre-programmed instructions. It is widely used in manufacturing for precise machining of materials such as metal, plastic, wood, and composites. Cnc Automation improves production speed, accuracy, and efficiency while reducing human errors. How Cnc Automation works. 1. Design and programming. A CAD, computer-aided design, model is created to define the shape of the product. The CAD file is converted into a Cnc program, G-code, using CAM, computer-aided manufacturing, software. The G-code contains precise instructions for machine movements, cutting parts, and tool operations. 2. Machine setup. The workpiece, material to be machined, is placed and secured on the Cnc machine. The appropriate cutting tools, drills, mills, lathes, etc., are selected and loaded. The machine is calibrated to ensure accuracy. 3. Automated machining process. The Cnc machine follows the G-code commands to perform operations such as cutting, drilling, milling, turning, and engraving. Sensors and automation systems monitor and adjust machine operations in real time. Some Cnc systems use robotic arms for material handling and tool changes. 4. Quality control and finishing. Automated measurement systems check the accuracy of the finished product. If needed, the part undergoes additional finishing processes such as polishing or coating. Completed parts are removed, and the next workpiece is processed automatically. Types of Cnc machines in automation. 1. Cnc milling machines, used for cutting, drilling, and shaping materials with rotary tools. 2. Cnc lathes, perform turning and shaping operations by rotating the workpiece. 3. Cnc plasma cutters, use plasma torches to cut metal sheets precisely. 4. Cnc laser cutters, use laser beams for high-precision cutting of various materials. 5. Cnc routers, ideal for woodworking, plastic, and soft metal cutting. 6. Cnc grinding machines, used for precision grinding and finishing operations. 7. Robotic Cnc systems, integrated with robotic arms for automated material handling. Advantages of Cnc Automation. 1. High precision and accuracy, produces complex parts with minimal errors. 2. Increased production speed, operates continuously with high efficiency. 3. Reduced labor costs, requires fewer manual operators. 4. Improved safety, minimizes human exposure to hazardous machining environments. 5. Consistency and repeatability, every part is machined exactly as programmed. 6. Versatility, supports a wide range of materials and complex designs. Applications of Cnc Automation. 1. Aerospace industry, producing aircraft components with high precision. 2. Automotive industry, manufacturing engine parts, gears, and frames. 3. Medical industry, creating surgical tools, implants, and prosthetics. 4. Electronics industry, cutting and drilling PCB boards. 5. Metal fabrication, producing customized metal parts for industrial use. 6. Furniture and woodworking, automated carving and shaping of wood-based products. Integration with smart manufacturing. Industry 4.0. Cnc Automation is evolving with Industry 4.0 by integrating 1. IoT, Internet of Things, for real-time monitoring and data collection. 2. AI and machine learning to optimize machining processes and predictive maintenance. 3. Robotic automation for autonomous production lines. 4. Cloud-based Cnc systems for remote operation and control. conclusion, Cnc Automation has revolutionized the manufacturing industry by increasing efficiency, accuracy, and production speed. With advancements in robotics, AI, and IoT, Cnc systems continue to evolve, making factories smarter and more automated.